we present DragDiffusion, harnessing diffusion models for interactive point-based image editing, a highlight paper in CVPR 2024. Empowered by the large-scale pre-trained text-to-image diffusion models, many impressive generative image editing results have been achieved. However, most of such editing methods rely on text to convey the editing intention, which lacks flexibility and pixel-level preciseness. One notable work enforcing precise spatial control is DragGAN. In this work, the authors implemented interactive point-based editing on generative adversarial networks. Specifically, the users only have to click handle and target points, and then the model will move the semantic contents of the handle points to targets. Although DragGAN demonstrates impressive flexibility and precision, its main drawback lies in the generality. Since this method is built on top of GAN models, its applicability is constrained to the few domains where GAN models are trained on. To bridge this gap, we introduced DragDiffusion, a method that facilitates precise drag-based editing using large-scale diffusion models. Our approach extends drag-based editing capabilities to real images across various open domains, significantly enhancing the applicability and versatility of such editing techniques. Due to the multi-step nature of diffusion models, we cannot directly shift the DragGAN to diffusion models. Therefore, we first take a close look at the output features of the denoiser network on different diffusion time steps. Interestingly, we find that spatial structure of the generated images are already well captured at a certain time step, say the 35th step. This observation implies that manipulating diffusion latents of one single step might be sufficient for achieving drag-based editing. Motivated by the previous observation, we designed the following pipeline. To start with, given the user input image, we fine-tune a LoRa to better reconstruct the image from the noisy latents. This fine-tuning process only takes about 25 seconds on a A100 GPU. Then, based on the fine-tuned LoRa, we invert the source image into a diffusion latent and optimize the latent according to the user editing instruction. Finally, when denoising the optimized latent to obtain the results, we apply a reference latent control, which markedly improves the consistency between the editing results and the original image. Here, we evaluate on the effectiveness of conducting consistency fine-tuning and reference latent control. As can be seen, when combining all these components together, our approach yields the best results. Here, we show more results to demonstrate the effectiveness of our method. Moreover, our approach is even more robust when dealing with diffusion-generated images. What's more, our approach can even handle drag-based editing with very large magnitude, such as those dragged across the diagonal of the image. Although DragDiffusion has significantly advanced the generality and applicability of drag-based editing, it still suffers from problems such as high response latency. To remedy this, our follow-up work, InstaDrag, dramatically reduced the latency of drag-based editing to less than 1 second. What's more, InstaDrag significantly outperforms previous methods in terms of consistency and accuracy. Thanks for listening. If you are interested in our work, feel free to reach out to Yujun.